Okay, our main focus in this learning target is to actually solve some differential equations. But the primary method we're going to use is one you've already seen. The method we're going to use in AP Calc to solve differential equations is to separate the variables. Get all the x's and y's separated, get the x terms on one side, get the y factors on the other. And then once that's accomplished, we should be able to integrate both sides. So if I look at this, here's maybe the first example you and I might work together today. We've got the differential equation dy dx equals 2x over y. And we showed you this previously. I think we can treat this scenario like a proportion from your earlier math, where I can use that cross product property to multiply together y and dy. It's just one of many legal moves. And that would have to equal then the product of the other two parts, 2x dx. And the advantage to that step, I hope you see by now, is that I have separated my variables. I've got all my y things on the left side, all my x things on the right side. So my step here is to integrate both sides. So the antiderivative of y dy, well, that's y squared over 2. Technically, I'm supposed to put a constant of integration here, like plus c, but I'm going to leave it off for a second, and I'll talk about why. On the right side, I need the integral of 2x dx, and that's x squared. Now I'm going to put the constant here, and here's why. Technically, I'm supposed to have a constant of integration here and a constant of integration here, but since they're both arbitrary constants, I'll just subtract this arbitrary constant from both sides, and I'll call that c. Now the only thing I've got to do here that I'm neglected to do so far is that I need to solve this thing for y. So I'm going to multiply both sides by 2, and I'll say that y squared would equal 2x squared plus, and I could write 2c here, but again, since c is an arbitrary constant, 2c is a constant also. Let's just call that c. Okay. And my last step, my solution step, the thing I need to get y by itself, is to take the square root of both sides. So y would be the square root of 2x squared plus some arbitrary constant c. And the one thing I got to remember here too, that is if I take a square root, any even root, second root, fourth root, plus or minus needs to be in here because either one of those options actually solves this scenario. So right here is what we call this the general solution of a differential equation. Here it is, y equals plus or minus the square root of 2x squared plus some arbitrary constant c. So we call this the general solution. And we call it the general solution because of that c. I can't give you a specific value for c. We'll work some problems in a little bit where I will give you a specific value for c, and then we don't call that the general solution anymore. Okay, here's another example to share with you. It says solve dy dx equals x times y. My first step, well, I need to separate variables. And I think if I divide both sides by y and multiply both sides by dx, I can get here. This really is a key step, folks, in that if I can't get the variables separated, oftentimes on the AP exam, they will give you a problem where they ask you to solve a differential equation as part of the free response. And if you don't even, usually those will be worth like 4 or 5 points on one of the free response because it can be complicated and there are a lot of steps. And if you don't separate your variables, they usually won't give you any points. But what I've done here is that I have separated my variables, so I'll integrate. Now the antiderivative of dy over y, that's like 1 over y dy. So my antiderivative is ln of y. And the antiderivative of x, how about x squared over 2 plus some arbitrary constant? Now, I need to solve this for y, so I'll take e to both sides. But if I take e to the left side, I'm just going to get y. The right side should be e to the x squared over 2 plus c, and notice that plus c is part of the power on e here. All right, I need to use a trick here to get to the best answer from algebra class. If you have a base to a sum of powers, that's the same as the base to the first power times the base to the second power. This is the trick we use when setting up our y sub 0 in the last learning target with growth and decay. But now, e to the c is just some constant. Because if c is a constant, e to the constant power is some number also. So I'm just going to choose to call that number the constant. I'm going to call that c. And I usually put that up front, c times e to the x squared over 2. And that equals y. And there's my general solution here. And whether or not you made this step happen last time, the last learning target, we need to really try our best to make that happen this time. Let's look at one more example, and then I'll ask you to try a little bit of this on your own. We want to solve the differential equation dy dx equals x plus sine of x, all divided by 3y squared. I believe the separation technique happens here again with straight up cross product property. I know that 3y squared dy would then have to equal x plus sine of x dx. And I think I've got separation. Y is on one side, x is on the other, so I will integrate. So I've got the integral of 3y squared dy. Oh, that's y cubed. And the integral here I can do term by term. I've got a sum of two terms, so I can integrate each term separately. The integral of x would be x squared over 2. And the integral of sine, the function whose derivative would be sine, I believe is negative cosine of x. And I still need to include my plus a constant. And other than solving for y, I believe I'm finished. And my trick to solve for y would be to take the cube root of each side. So y equals, I need the cubed root of, let's do x squared over 2. Minus cosine of x plus c. And I would point out to you here that I don't need plus or minus because I took a cubed root of both sides. That's a trick that I only use when I take even roots. So if I take the cube root of each side, I don't need plus or minus. It turns out that the only way to get a positive thing if you cube it is to have had a positive thing to begin with. Okay, I do want to backtrack to the second example you took. I hope you left a couple of lines here. I want to show you this step. I want to show that my solution solves the differential equation. Okay. So if I take the original differential equation I got, dy dx, this is not something that you're often asked to do, but this is a good way to check your work. Okay. So suppose I were to use my answer for y and figure out what dy dx was based on my answer. In other words, I'm just going to take my answer and take its derivative. Well, I've got a constant times e to the something. And the derivative of a constant times e to the something is the constant times e to the something. And then if I use the chain rule, I need to multiply by the derivative of my something. Well, the derivative of x squared over 2 would actually just be x. So this part's the chain rule. But all I've got here is the product of x and this, which I called y over here. So it turns out, yeah, this function satisfies this differential equation. Because if I take what I got for my answer and differentiate it, I'm going to get an expression that's equivalent to x times y. This is not always an easy thing to do, but for some pretty straightforward differential equations, this is a good way to check your result.